Hello, hello. I hope you're having a wonderful on-passive day. I know that I am. Today, I want to talk about some on-passive tech stuff or tech stuff in general. So, we're going to be talking about hybrid data centers and understanding what IPs are. We'll touch briefly on databases, security control, and even network access storage, what we call NAS systems. So, if you bear with me here, we're going to start talking about some data centers and give you a little context because over the last few years, we've seen the amount of data in the world increasing rather rapidly and exponentially, I might add. And to support the applications required, businesses are looking for a flexible, more secure infrastructure solution. And today's economy requires that solution, that infrastructure, be rather dynamic, almost fluid, to borrow Mr. Mufara's term, and one that allows brief access to every service that's out there. Now, these types of facilities are being recognized as an ideal solution to scalability and security and will help our business, leverage new technologies. For this reason, it really shouldn't be any kind of a big surprise that OnPassive, which is continually double stacking the cool, has initiated developing its own hybrid data centers. So, simply put, a hybrid data center is a facility that has a combination of computing and storage environments. And by using the hybrid IT infrastructure environment, we combine the benefits of on-site or on-premise, which is what some of the texts call on-prem, data centers with private and or public cloud services. And doing this allows rapid response to changing business needs, and it provides the ability to gain comfortable control and flexible things regarding our workloads, which is extremely important because these workloads are actually placed in different areas. They can be in a private cloud, which refers to a model of cloud computing in which computing resources are rented in a single client or a company, and they're dedicated to the needs and goals of that particular business. They can also be in a public cloud, meaning that this is where data is stored offsite on a shared server that's managed and maintained by that type of a service provider. They can also be on site, what we call on prem, and that's where resources are deployed in house or within our own data center. So that's what we're doing. That's exactly what OnPassive is doing with the data centers because it is absolutely ripe right now with all of our digital resources and our online ability, right? Our online technology, that we do not want to be housed in somebody else's data center because it just would not be real good for us long term. Now, understanding IP addresses. That's something that's been tackled on the webinars here, and it gets a little confusing, but just know that every device connected to the internet needs to have something that identifies it. The internet protocol, right, the IP as it were, is a procedure. It's a set of rules for routing and addressing groups or packets of data so that they can travel across networks and arrive or get to, a right destination, a correct destination. Now, they have what's called an internet protocol suite, right? Commonly, that's known as TCP/IP, and this is a set of communications protocols, more than one, used in the internet and similar computer networks. ARPA, net, things like that, government facilities or government-run nets as well. Now, the current foundational protocols in this suite are the TCP protocol and the IP protocol. So that's where we get our IP protocol from, that suite. Now, the IT protocol addresses that we're familiar with, they're all numerical addresses, and they're used to identify a particular piece of hardware that has been connected to the internet. Now, every piece of hardware that's connected anywhere, right, called a node, N-O-D-E, that has an internet connection has one of these IPs, an internet address, right? But each device or node can have more than one address because nodes have what we call interfaces, and each interface can have an address. So it could get pretty complicated, and the number of IP addresses needed could go up really quick. And there's hardly any amount that we won't hit sooner or later. I mean, it's just crazy how many IP addresses we've got and how many we can use, right? Now, there have been several interested, well, there's been a lot of previous, I'll put it this way, there've been a lot of instances of previous versions of IP, right? They had version 0, which is in a reserve status. Versions 1 through 3 are unassigned or otherwise not in use. Version 5 is obsolete. So consequently, we have two that are the most common versions, and that is IP version 4 and 6, right, known as IPv4 and IPv6, respectively. At this point, we should also point out that the definition of a bit, bit, right, is a digit in the binary numeral system or numeral system, and it is a basic unit for storing information. And that's important because IP addresses, in particular the IPv4, provides a 32-bit IP addressing system, right, with 4 sections. Now, if you want an example of that, if you go, you look at an address that looks like 192.68.0.1, that's what an IPv4 address might look like. Incidentally, for those of you that have consumer routers in your house, that is a standard address for a default router for IPv4. So you've probably seen that before, right? Now, the IPv4 supports almost 4.3 billion addresses. Now, if you really think about that, and then you think about our market cap, which is approaching 5 billion, you can probably see why this might be a problem, since we've got, right now, more internet users than we have addresses. Not to mention, those users can have multiple devices, and those devices can have multiple addresses, right? This is a problem commonly referred to as IPv4 address exhaustion, as you might imagine, because there simply aren't enough IPv4 addresses available for all IP use cases, which is phenomenal, in my opinion. I mean, we've even gotten that big. So, however, if we contrast that to the IPv6, right? IPv6 defines a 128-bit address space, which provides a whole lot more, I mean substantially, gazillions more space than the IPv4 did, with a whole lot of, lots and lots of trillions of address. I mean, it's a big number. We'll get to that, right? To get to the real gist of this number, I went and looked at redhat.com. The IPv6 can, theoretically, I suppose, allow 3.4 times 10 to the 38th power unique IP addresses. Yeah, that's a big number, right? Incidentally, I went to redhat.com. A Red Hat hacker is a hacker that takes aggressive steps to block or to stop black hat hackers. You gotta love this, right? Well, a black hat hacker is a criminal that will break into computer networks with some bad intent, malicious intent. So that's what that's about. And to get a good understanding of this number that I just gave you with the 10 to the 38th power, you could read that as about 340 trillion IP addresses. Now, if you really want to get the enormity of it, the actual number is, well, it's way too big to read. So, you know what? I'm going to put the text version over here on the slide, and you can read it because it is crazy. But I just use the term a gajillion. So there's a gajillion addresses, and you can see that it's huge, and it's that massive availability of address space that's provided for or provided by the IPv6 system that really is the primary benefit. And that's what we're going after, and that's why Mr. Mufara is so interested in making sure that we have that for ours, right? Now, Needless to say, with that number of addresses, we are never ever going to have to worry about running out of addresses. But the challenge is with IPv6, so we can give Mr. Mufara and his team their due, right? Is that there's so many numbers. It's so big. It's complex because it's really challenging for network administrators and techs to monitor and manage that, especially in real time, like I know Mr. Mufara is doing through their software and through their AI. So, incidentally, you may have heard, I think it was on a Monday webinar not too long ago, where Mr. Mufara talked about ONPASSIVE's IPs never being able to be blocked, right? Well, technically, this is because ONPASSIVE is not promoting itself. It's promoting, it's branding, in a way, the members of ONPASSIVE. And if a member's IP gets blocked for some reason, the system is going to automatically reassign another IP address, and it's going to keep right on going, business as usual. So those people looking to block, they got a moving target, brother. So I hope you enjoy that, and I hope that makes sense for you. Let's talk a little bit about databases and some uptime, downtime, latency, that sort of thing. Databases, well, they're used for storing, for maintaining, and for accessing all sorts of data, right? That information is all gathered, is put into one place so it can be observed and it can be analyzed so that we can use it, right? Now, in computing, a database is organized as a collection. It is stored data and it's accessed electronically. Small databases can be stored on a file system. Say, for instance, maybe you've got, I don't know, a list of ingredients and you put them in an Excel spreadsheet. That is a very, very, very basic data base in a sense. However, the large databases, right, the big ones, those are the ones that are hosted in computer clusters and data centers and cloud storage, right? So ONPASSIVE uses databases. It's got a huge one. It's got all its information, its locations, its founders, its employees, its finances, its products, its company's profiles, everything in a very big database, and it uses that database to manage every aspect of the business, because you can go in and you run queries, you can sort stuff, and it's miraculous what it can do, right? So let's go over a few terms that'll probably be good to know if we want to understand a little bit more about databases. Now, we've also heard Ash and other techs on webinars and such talk about active and passive databases, and could be confusing, but don't lose any sleep over it. I mean, trust me, ONPASSIVE's got a lot of things to be excited about, and you're gonna have a whole lot of reason to be losing sleep, right? A lot of opportunity for that. So this ain't one of them. Anyway, an active database is one that is currently being used by the clients that have mailboxes in that database, and all the transactions for the database are being generated by the server it's on. A passive database is one that's not currently being used by clients. So that would kind of make sense. It is therefore not generating transactions. It's inactive. And you've probably also heard of uptime and downtime. Well, these terms refer to network activity. Now, uptime is talking about the time when a network is up, it's running and it's active. Downtime is when it's not, right? It's the time the network is not active, it's not running, it's not available. Now, a network's uptime is typically measured by calculating ratios of uptime to downtime, and the period of time for that to calculate is a year. So they do it within a year. All that being said, this stuff is important because accounting needs to know about downtime, because downtime can be very expensive to a company, right? Now, one of the things that you've also probably heard Ash and others talk about is the word latency. Network latency, which is also called lag or lag time, is the amount of time that it takes for a data packet to go from one place to another and back. In simple terms, It's the amount of time a data signal goes from point A to point B and then back to point A. In context, more and more organizations, like ONPASSIVE, have future successes that are tied to digital online business, right? As digital customer experiences expand, their brands rely, more and more, I guess, on applications that are hosted on different infrastructures, in different geographies, and even with different providers. So there's a whole series of things, right, that can come into play because there's a whole mixture here, and arrangements like this can have a very complex effect on what's going on, and the number of components that make up an application can put a strain on the performance. It can degrade user experience. It could also risk losing customers. So hence, timing is a huge issue. Latency is a big, big issue. And there's actually a new adage out there that says, quote unquote, latency is the new outage. This simply means that slow products and slow services can be just as damaging to a business bottom line as not having them available at all. And that's why Mr. Mufareh probably made a very good point of mentioning it. Now, to better understand this, let's take a look at super fast broadband. Everybody knows fast broadband. Man, it's like a gold standard, right? Or close. Well, maybe fiber optics is, but you get my point. A round trip data delay of 10 to 20 milliseconds is pretty normal for super fast broadband. If there are some gamers out there, right, a delay in about 20 to 40 milliseconds range, that's considered optimal. Anything under 100 milliseconds, like 1/10 of a second, is usually pretty good for gamers. But you could look at it this way. If, as a gamer, you've got a lag of 1,000 milliseconds, which is like 1 full second, man, you are going to have people appearing and disappearing all over that screen willy-nilly, and that is not going to make for a very good gaming experience. So it's easy to see why lowering our latency is important to building good user experiences, and why it's so exciting to think that ONPASSIVE latency is going to be at 0 or so close to 0 that you're going to have to work just to be able to see a difference. All right. Now, I hope that is understandable. I know I'm going kind of fast and get a little screwy, but let's talk a little bit about security and security control. Now, security controls are used to protect and to prevent loss or compromise. Data security controls are used to protect and prevent loss or compromise of data. It safeguards sensitive and important information, and it's a countermeasure against that information's unauthorized use. And these controls help to counteract, detect, minimize, and avoid security risks to computer systems, data, or information sets, like databases. Security controls help reduce the risk of data loss or damage by deterring, by slowing down, or by stopping any possible malicious attack on our data assets. So, I hope that's good. Network access storage, we've talked about that. Ash mentioned it, and he talked about the employees and that sort of thing. So let's take a look at it, what we call the NAS. Now, an NAS system is a storage device that's connected to a network that allows storage and retrieval of data from a centralized location for authorized users of that information. ONPASSIVE uses these systems. They're flexible and they're scalable, which you would imagine, knowing Ash, right? Meaning that as you need additional storage, you can add on to what you have. It's like having a private cloud in the office. It's faster, it's less expensive than conventional methods, and it provides all the benefits of a public cloud on site, on-prem, and it gives you complete control. Now, with NAS, data is continually accessible, making it easy for employees to collaborate and respond and follow up, right, with information, because all of it's in one place. Because NAS is like a private cloud, data can be accessed remotely, right, like we do with anything else, using a network connection. And that means employees can work from anywhere anytime. And that's what Mr. Mufara was talking about. And that's a big deal, as this concerns things like insider threat or accidental or even lost this intentional, right? Because the data being accessed is located in a central spot. It is not located on that device. It's not located on the PC or the laptop or the phone or whatever device is accessing the data. So that data can't be taken from that device, right? If that device is lost or stolen, then there's no data of value on the device to be accessed or taken, right? All that data is kept on-prem, safe, and sound. So life is good. And he is really looking out, Mr. Mufar is really looking out for our best interests and the best interests of ONPASSIVE with all these security measures. And there's a lot more than that. But having said all of this, I'm kind of done with the tech stuff. This is or is meant to be a revamp or a rehash of some of the stuff that we heard the other night on one of Lynn's webinars, which was a wonderful webinar, and I certainly appreciate her and all that she's doing and those techs that get on there and spend their time. Keep in mind, please, ONPASSIVE is going to provide all the digital tools and services that we need for an online presence. They're going to be safe, they're going to be secure, they're going to be affordable, complete, and cutting edge, and we'll guarantee your success. You just got to get in. You just got to join and get active. So check us out. Get your life unstuck. If you've already been invited, please reply back to the founder that invited you to join. If you weren't, well, click in the link in the description box below. Join with us right now. For more information, you can also go to ONPASSIVE. And just keep in mind that whatever you do, whatever you decide to do, for whatever you want to do for your future, just know that we wish blessing and blessing upon you and upon your entire family as well as your future. Thank you. Bye.